Hello, everyone. Welcome to the UCrew video lecture series. Today, we're going to be giving a broad stroke introduction to the UCrew, what we do, how we do it, and who we do it for. Quick roadmap of what's ahead. We're first going to get into a little history of our program, then a little bit about who we are and what we do, and then get into what an assessment looks like with us. First, want to provide a little bit of context to our organization in particular, since it can be a little bit confusing and there's a lot of acronyms. You work for the Utah Center for Renewables, Efficiency, and Workforce, or UCREW, which is part of the Energy and Geoscience Institute at the University of Utah. The UCREW conducts both commercial and industrial assessments. The industrial assessments fall under the larger Industrial Training and Assessment Center program, which is administered by the U.S. Department of Energy, which we'll get a little more into in a bit. There are some commercial ITAC assessments as well, but most of these fall under other funding sources, like BERP, which is the Beehive Emissions Reduction Plan. This is a program of the Utah state government, and these assessments are not reported to the Department of Energy. To start, a little bit of background of how the ITAC program began. The history is a little nuanced and complicated, so I'll do my best to summarize it. To make a complicated history short, in 1973, Israel was invaded by several of their neighbors, and as one of their strategic allies, the United States provided them military and economic support. This really angered the invading countries, who were part of the Organization of Petroleum Exporting Countries, or OPEC, who then decided to artificially raise the price of oil to punish the United States, who was heavily reliant on foreign oil. This started the 1973 oil crisis. The embargo was lifted the next year, but not before prices nearly quadrupled. This really hurt the manufacturing sector of the United States. A lot of manufacturers worked on very slim margins to begin with, and seeing increases in costs like this really hurt a lot of business and put a lot of them under. So much so that in 1976, the Department of Commerce created the Energy Analysis and Diagnostic Centers, or EADCs, or what we now know today as the Industrial Training and Assessment Centers, ITACs. And its purpose was to help out American manufacturers and keep them competitive by cutting back on any unnecessary costs and inefficient energy usage. One thing that is funny to mention is the ITAC program actually predates the Department of Energy, which was created the following year in 1977. The year after that, the Department of Energy acquired the EADCs. Since then, our purpose hasn't changed too much. We help increase the competitiveness of U.S. manufacturing by lowering their utility costs, but we have expanded to focus on implementation of energy management systems, cybersecurity, air quality, and on research into energy-saving mechanisms and energy systems. And lastly, since it's good to know who you're working for, the program is administered through the Advanced Manufacturing Office under the Office of Energy Efficiency and Renewable Energy. Just to reiterate, our mission has not changed a lot. Our purpose is to increase U.S. manufacturing sector competitiveness by providing no-cost technical services. To put it simply, our job is to provide a no-cost energy assessment to small and medium manufacturing businesses. And I'll get more into what that means in a few slides here. Basically, what we're doing is looking for energy-saving opportunities. These are projects that the client can do on their own that will help save them money in one way or another. Now, to be clear, we are not an engineering design or project management firm. We do not oversee the application of any of these projects or their implementation. We simply provide the ideas to our customers and they can pursue it on their own. Now, in everything we do, there's a whole lot of benefit to the businesses. First off, there's no cost to them whatsoever. We're entirely funded by the Department of Energy. All they have to do is provide us some time and some of their interaction. Not only is the assessment at no cost, the Department of Energy also has a grant program that can help cover the cost of implementing our recommendations. In this way, even if it's a project they were already considering, they can now do it at a cheaper cost than they otherwise would have been able to. Additionally, there's no contractual obligation for them to do anything, meaning there's no risk for them to perform these assessments. They either like the ideas we come up with and decide to pursue them, or they don't and they've lost nothing. One of the last benefits that is often overlooked is that this is entirely confidential, which is very important to a lot of businesses. For instance, let's say that a business is looking to buy a new boiler or a new air conditioning system, and they tell us that. We keep that information confidential so that they don't have contractors swarming them to try and get their business. This is also an important guarantee for businesses such as defense contractors, who take security very seriously, who can use our services and know that their data, utilities, and projects are safe. One of the biggest advantages of working at the UCrew is that we're part of the National ITAC program. This means that apart from having a center here at the U, we have a number of centers at different universities across the country, and this is something we can leverage to our advantage for both our academic and professional growth. We have events where we network with other students at different ITACs, as well as having access to professional resources through our cloud sharing service Box. If you go onto our box, you'll see that we have a number of files from these different ITACs, whether it be previous ARs, technical documents, or tools for identifying energy saving measures. You can find all this information on our box, so definitely a big advantage of being in the ITAC program. In addition to students like yourself, we also have several professionals that are part of the U Crew. Dr. Cody Powell and Julie Sieving are the co-directors of our program. Dr. Powell is a professor in the chemical engineering department and does a lot of work in energy systems and dynamic simulation. Julie is a professional engineer with many years of experience in the consulting role. Dr. Dave Wagner is also a professor in the chemical engineering department and serves as assistant director. Glenn Anderson is a professional engineer with many years of consulting experience and focuses primarily on commercial assessments. Creed McCord is a program engineer who also works on commercial assessments. Brooke Tucker is a program manager focusing more on the business and marketing side of what we do. And apart from those professionals, we also have a number of graduate and undergraduate students working as part of the program. On each assessment, there will be a professional lead, one of the people mentioned in the previous slide, who has a lot of experience and can help guide you in the right direction. There will be an assessment team lead who's a student like yourself that's been here a while and has a lot of experience going on these assessments. And lastly, there will be the other students on the assessment, usually 4 to 6. Hopefully at this point, now that you know who we are, you're wondering who it is we work with. Well, we work predominantly with small to medium-sized manufacturers. Now, how do we quantify that small to medium? Well, we have several criteria that our customers need to meet to be able to work with us. The first is that they have to spend at least $100,000 in annual energy expenditures, but they can't spend more than $2.5 million. Additionally, they have to have less than 500 employees per plant, and they cannot make more than $100 million in gross annual sales per plant per year. Now, the reason for working with small to medium-sized companies is that we're really not supposed to work with the giant corporations of the world. Those are large companies that already have the resources, time, and money to look for energy-saving opportunities like this on their own, and that's an expectation they should be held to. Many large corporations like this already have dedicated energy management teams for that exact purpose. On the other hand, small to medium-sized manufacturers don't really have the time or resources to look into this kind of thing on their own. This is where we come in to help them be more competitive by doing these assessments that they wouldn't have the opportunity to do by themselves. There are some asterisks in there that I'd like to address. Because we're funded by the Department of Energy, we do often work with institutional customers. This could be schools and universities, and a lot of the time water treatment facilities and water distribution plants. And that's mostly for the professional development side, your professional development. Additionally, you'll notice we use the phrase per plant a lot when talking about that small to medium sized criteria. Often we'll have customers meet most of these rules, but maybe fall short in a few places. What we can do is split an assessment in half and work with two different plants which meet those criteria. Those are the exceptions that you'll typically see. Okay, now we're going to get into the juicy part of this presentation, the assessment process. For industrial assessments, this can be broken down into 4 sections: the pre-work, the plant visit, analysis and write-up, and follow-up. We're going to go through each of these one by one. The assessment process starts with pre-work, where we reach out to the client and schedule a site visit. If they're interested, we schedule a visit date and ask them for 1 year's worth of relevant utility bills, such as electrical, gas, water, etc., whatever they're wanting us to take a look at. This part is incredibly important. It's amazing how much you can learn about a facility just through their utility usage. At this point, the team lead is going to talk to the assessment team about the facility, what they do, and try to give them a general overview. Additionally, they'll talk about some of the equipment at the facility, and we'll usually assign members of the team to research these equipment, such as air compressors, to give them a better understanding of what they're looking for and some ideas for energy savings. Plant visits almost always take place over the course of 1 full day. Very occasionally, you might see them spread out over 2, but they typically follow this routine. In the mornings, we'll meet with the plant management and learn about the facility and their process. This step is very crucial. These people have worked in this plant day after day, year after year, and know the facility better than anyone. Facility staff are always a fantastic resource, and it's important to listen to them and find out what their goals are and what they find the most valuable. These are the people that'll be reading our report and who you have to sell these ideas to, so it's important that we're all on the same page. A lot of the time, the facility staff will already have a couple of ideas and can point you in the right direction. This is followed by a guided tour of the facility where you'll get to see their process and the equipment we'll be focused on. Next up is the step we all look forward to, lunch. Perk of going on these assessments is the U Crew covers your meal. Sometimes the facility brings lunch to us and we'll eat together in a conference room, and other times the team will find a place to eat close by. These are working lunches, so everyone gets a little time to eat, and then we move on to discussing what we've seen so far and any energy saving ideas, or as we call them, assessment recommendations, that we've been able to come up with so far. This time isn't about coming up with perfect ideas that are 100% going to work. It's just about throwing as much stuff at the wall as possible. And most of it won't stick, and that's okay. We often come up with 20 to 30 ideas in this phase, which get whittled down to between 4 and 8 full-blown ARs during the assessment process. After lunch, we have a better idea of some of the recommendations we're going to work on, and we can figure out what information we need to make them work. This is where we'll take measurements, photographs of the nameplates of equipment, ask additional questions to the facility personnel, and install data loggers which track the use of electrical equipment that we're interested in. Just to give you guys a glimpse into some of the recommendations we provide, we have a couple bread and butter kind of measures that can be recommended to a lot of our customers. Some of these can be low-hanging fruit, which is great for us. Replacing old fluorescent light bulbs with LEDs is easy and makes for quick savings. Similar things can be said for adjusting the set points of HVAC equipment or air compressors, things of that nature. This could be saying something like, hey, you're keeping your AC on at night when no one's here. Turn it off when no one's in the building and you'll save a bunch of money. Or your air compressor is producing air at 130 psi, but your equipment only needs a pressure of 100 psi. You can turn that down. We also provide some more advanced recommendations, like building automation systems that tie all of the facility's HVAC equipment into a central control system, battery storage systems, solar panels, power factor correction, combined heat and power. Don't worry if some of these terms are unfamiliar to you right now. We're not going to throw you too far into the deep end when you're just getting started. And at any rate, we have lots of great people and resources to help you when you eventually do take on some more of these deep cuts. At this point in the process, we've visited the plant, gained some information from the facility staff, and have come up with some energy saving ideas. After the assessment is when we engineers can get excited because it's time to analyze the data and quantify the savings. We get to pull out those fun thermodynamic equations or relations from technical documents to help us calculate the savings for our ARs. This process typically takes 4 to 6 weeks, although this can change a bit depending on the time of year, whether we're getting close to finals, that kind of stuff. Part of this process is AR presentations, where you'll present the recommendations that you've been working on, your calculated savings, and your implementation costs to your team. This might sound scary or intimidating, but this step is all to help you in developing the best recommendation you possibly can. No one's out to criticize you, just to give you feedback on how you can improve your calculations and reasoning. Through this whole process, our goal is to produce at least 3 ARs, which is the minimum set by the DOE for all our reports, all with a reasonable payback period. If there's any number in the entire report that the facility is going to look at, it's the payback period. This is the implementation cost divided by the calculated savings and tells them how long it will take for the project to pay itself off, which is super important for justifying to these businesses why they should be willing to spend their hard-earned money on the project. For example, if the AR to replace old light bulbs with LEDs saves them $250 and costs $500, it'll take 2 years for the savings to offset the initial cost of the project. Once you've finished AR presentations and have had some revisions to your calculations, it's time to start writing the report. The report that we ultimately present to the customer has many parts to it. We start with some initial sections: the facility information, where they are, what products they produce; the process description, a step-by-step guide of how they do what they do and produce their finished products; list of major consuming equipment, like compressors, pumps, chillers, HVAC, that type of stuff; and best management practices, giving credit to what the facility is already doing well and should continue. There's also an energy and waste accounting section, which goes over the facility's utility bills in depth. We'll go over electricity, natural gas, water, and other things like wastewater or propane if they're relevant to the facility. This section is also where we'll get our unit costs, or how much money they're saving per utility being saved. This would be dollars per kilowatt hour for electricity or dollars per MMBTU for natural gas. These are the unit costs that you'll use in your own savings calculations. And again, we're trying to identify at least 3 ARs, though we usually have more than this. And our goal is to try and save 5 to 10% of their total utility bill. We have another section for additional considerations, including cybersecurity, which contains some valuable information for customers that are interested in that. We also include what we call additional assessment recommendations, AARs or double ARs. These come from some of those ideas that we initially had for ARs, but they didn't fully pan out for one reason or another. This could be because they do have fully fleshed out calculations, but the payback is really long. Or there might be really good savings, but we just don't have the necessary information or data to accurately quantify it. These don't get reported into the DOE database like the ARs do, but it's a nice way to include more good ideas for the customer. We also include a section on air emissions calculations, which relate the utility savings from our ARs to how much that would be saving in emissions into the atmosphere. Lastly is the conclusions, where we summarize our findings and sum up all of the savings numbers. At this point, the rough draft of the report is complete. We'll go through a team review where everyone gets a chance to look through the report or specific sections and check for any spelling or grammatical errors and see if anything doesn't make sense. As a newer team member, this is where you are especially valuable. A lot of the time, the person who ends up reading our report may be more of a business person and not have a solid engineering background or foundation. If a section doesn't make sense to you, there's a good chance it won't make sense to whoever's reading the report. After the team review, the team lead will give a final read and send it off to the professional lead. The professional lead will read through the report and make comments, suggestions, and edits, and then there will be a meeting where they can discuss all this with the team. The team makes this round of edits and then submits it to the ITAC database for review. The report then gets reviewed by the ITAC field office at Rutgers University in New Jersey, where they get the final review for all reports from all the ITACs around the country. Our deadline from visiting the site to submitting the report to the database for review is 60 days, but we typically get it done sooner than that, so we aren't pushing right up against the deadline. Rutgers will review it and usually get back within a couple days. At this point, they'll either approve it or make some final, usually brief comments. We can then make our very final edits and resubmit it, and then the report is approved. After about 60 days plus the review period, the report is now ready to be sent to the customer. Once we've gotten the report approved and made it through that rigorous review process, it's time to deliver the report to the customer so they can read it and appreciate all that hard work you put into it. A few weeks after this, the team lead will have a follow-up meeting with the facility to go over the report and all of our recommendations so they can clear up any questions or confusion. The primary purpose here is to make sure that they want to implement the ideas that we have. One of the biggest success metrics for an ITAC and a big determiner of their funding is the implementation rate of their recommendations. Because of this, and also just because we want to help our local businesses save money, we really want to make sure that our customers accept the ideas that we have, and we want to make sure it works for them. So this meeting is a great way to make sure that they've read our report and understand the ideas we've had for them. At this point, we can sit back and finally take a nice long breather. About 6 months to be exact, because it's after this time that we'll contact them again to see which of our ideas they ended up implementing, which recommendations they liked, and if they didn't implement them, why that was. Hopefully at this point you're thinking, well, that's great, but does this actually work? And I'm so glad you asked that, because it really does. On average, we recommend about $140,000 of recommended savings per year per site. About 50% of that is typically implemented, which rounds out to roughly 2 million pounds of CO2 savings per year per site. That's the equivalent of taking about 200 cars off the road. As you can see, there's a tremendous environmental and economic impact from our work. This makes real differences for people's lives and for the businesses that we work with. And the businesses aren't the only ones that benefit from the work that we do. You benefit quite a lot yourself. To start with, you're getting real plant experience that you wouldn't otherwise get in the classroom or at other internships, particularly when you're talking about client interaction and technical writing. There's a lot of other things you can put on your resume. You can talk about real $10,000 to $100,000 saving projects that you calculated, brainstormed, and drafted up. There's a lot of bullet points you can put under your skills section, and I'm sure you'll be able to come up with more too. If any of that isn't good enough for you, and I know it's not a competition, but UCrew students make about $6,000 more per year than their peers upon graduation. So always nice to know that this experience and professional development is helping you make a little bit more money down the road. Now that you've heard about the ITAC assessment process, I want to pivot a bit to talk about the other type of assessments we do, commercial. While there are some regular ITAC assessments for commercial buildings, most of them follow a very different workflow. The work before the assessment remains largely the same. Once the visit has been scheduled, we get a year's worth of utility bills to analyze, and we have a pre-assessment meeting. Another important step is to do some good research into the building type, like hospitals, schools, etc., and figure out some common recommendations for those. One key difference between commercial and industrial is commercial customers are much more interested in energy benchmarking. This basically compares the energy efficiency of, say, a hospital to all other hospitals to see if they're relatively efficient in their energy usage. A common unit for energy benchmarking is EUI, or energy usage intensity, which is the total amount of energy used divided by the area of the building. The site visit for commercial assessments is pretty comparable to the first half of an industrial assessment. You'll meet with the facility personnel, get a tour of the building, and brainstorm some energy-saving ideas. Commercial assessments are almost exclusively HVAC focused, and most of these buildings have what are called building automation systems, or BASs. These are systems that control all the HVAC units in the entire building and can collect data as well. This is great for us because it means that we don't have to bring in and install our own data loggers. This is where the real difference between commercial and industrial assessments becomes clear. Commercial assessments are short. The week following the assessment is where you'll develop your ideas and calculations, then there will be presentations, and then the report will be ready to go back to the customer 2 weeks after the site visit. Now, you might be wondering, geez, the industrial assessment takes 2 months. How in the world am I going to get this done in 2 weeks? Well, there's no need to worry. It sounds a lot scarier than it actually is. Commercial buildings are much more similar to each other than industrial buildings are. The quote I like is that we're not reinventing the wheel, just repurposing it. Many recommendations will work and have very similar calculations across many different facilities, so these ideas take much less time to develop. Reducing energy consumption in commercial buildings is a very well studied field, so there's lots of great and fairly accurate assumptions, case studies, and industry rules of thumb to rely on. That's not to say that these calculations are less accurate than what we do for industrial assessments, just that you see a lot of the same kind of things on commercial assessments. Last, of course, is follow up, which is basically the exact same as for industrial assessments, and also not really your problem for now. Some other key differences I want to talk about that set these assessments apart, other than the much shorter time. Industrial facilities are largely focused on saving money. Some companies do have emission goals that they're trying to hit too, but most don't. Now, there's nothing wrong with that. After all, reducing your electricity or natural gas consumption does reduce your emissions, whether or not that was your goal. Many commercial facilities, however, are part of larger institutions such as universities or healthcare companies, and they do have overarching emissions goals most of the time. This means that some recommendations that reduce emissions but maybe have a longer payback period that industrial facilities usually wouldn't go for, commercial facilities might be more likely to. The other key difference is the difference in funding sources. Some commercial assessments are under that ITAC umbrella, like the industrial ones, but most of them come from other places and don't get reported to the Department of Energy. And I'd just like to finish this presentation by saying thank you guys for watching. I can truthfully say that I really believe in the work that we do. I really enjoy it, and it has a tremendous impact. So I truly hope you end up enjoying it as much as I do. You do some good work, and good luck.